Hello guys, and welcome to the channel. Today we're going to continue the Introduction to Limits, Part 2. I made 3 other exercises that will help us in solving different type of problems with limits. Okay, without losing any time, let's begin. We have exercise 1. The limit when x goes to 5 of the square root of x minus 1 minus 2 over x minus 5. Here we have a limit which has a square root in the numerator. One of the ways is what we explained in the previous video by multiplying with the conjugate of the square root of x minus 1 minus 2. But another very useful way is to replace it with a parameter t, or lambda, or whatever you want. This is also used in the case when you have the cube root. Okay, let's make the substitution. We have the square root of x minus 1 is equal to t, that is a parameter, and then x is equal to t squared plus 1. If we put it in the limit, we'll see that limit when t goes to 2, t minus 2 over t squared plus 1 minus 5, that is t squared minus 4, and we have the difference of the squared. We have the difference of the cubes, and the limit when t goes to 2 is t minus 2 over t minus 2 times t plus 2, and t minus 2 cancels out, and we end up with a limit when t goes to 2 of 1 over t plus 2, and that is equal to 1 over 4. Here we have changed the value below the limit, because when x goes to 5, then t will go to 2. We say this because we replaced x in the substitution above and this substitution here, and it turns out that t is equal to 2. Okay, let's move on with the second exercise. We have the limit when x goes to 0 of the square root of the cube root, of x squared plus 1 minus 1 over x squared. Even in this case, we will replace it with a t, the cube root. But attention to it. This will be done only in cases where you have only one cube root, because if you had the difference of 2 roots, then we would use the formula that tells us that the difference of cubes is equal to a minus b times a squared plus ab plus b squared. Okay, now the cube root of x squared plus 1 is equal to t, and x is equal to the square root of t to the third power minus 1. If you set this value to a limit, and the value it goes to is 1, then we'll get the limit as below. Limit when t goes to 1 of t minus 1 over t to the third power minus 1. And the limit when t goes to 1 is t minus 1 over t minus 1 times t squared plus t plus 1. And t minus 1 cancels out, and we end up with a limit when t goes to 1 of 1 over t squared plus t plus 1, and that is equal to 1 over 3. For this limit, we'll also use the formula of the difference cubed that we have done it here. Okay, let's move on with the exercise 3. In this exercise, we have the limit when x goes to 0 of sine of 3x over sine of 2x. In this case, we'll see that we have a sine ratio. To solve this, we have to look at the important limits. For these limits, we know that when the limit when x goes to 0 of the sine x over x is equal to 1. While above, we have sine 3x, and we have to divide and multiply it by 3x. And this is the same thing for the sine of 2x. Okay, here we have that the limit when x goes to 0 of sine of 3x over sine of 2x. That is equal to the limit when x goes to 0, sine of the 3x, we have divided by 3x and multiplied by 3x. The same as for the sine of 2x. Then the sine of 3x over 3x goes to 1. Sine of 2x over 2x goes to 1. when x equals to 0, and we end up with a limit when x goes to 0 of 3x over 2x. The x's cancels out, and the limit is equal to 3 over 2. Thank you so much. We'll see in the next video.